Okay, sixth grade. You guys are starting PSSAs next week. Some of you are starting it Monday, some of you are time. Eat a good dinner Sunday night as well, adding on to what Briar said. Charles? Good, eat a good breakfast. Mary? Awesome. Eliminate problems, answer choices that you know of, and don't stress about a problem. If you don't know something, you can always come back to it. Emma? Yes, go to the restroom before, get a drink before. Justin? Yep, have Kleenexes somewhere or in your classroom. Adam? You have to ask your teacher on that. If it was me, yes, but you need to ask. Doug? Doug? No, that's not true, Doug. Okay, but someone already said that. Eat a good breakfast. Not sugary, not a good idea, because you'll be a little crazy and then you'll. Not a good idea. Okay, that's better. Emma H. Don't what? Yeah, and Adam. Also, you know, if someone does get done and you're still working, do not let that stress you out. Okay, who cares? They're done. Let them do what they want to do. You take your time. Make sure you're thoroughly answering the questions. Make sure you're pretty confident that most of them are right. Don't worry about other people in the room. It's one thing that some of the ninth graders I have still worry about. Not you. Okay, don't worry about that. I get that all the time. Well, I failed the test because I felt like I had to rush because everyone else was finishing. Who cares? Okay, it's something in life you're going to have to learn to deal with. Worry about yourself. Take your time. Emma? Correct. Thank you. Now, hopefully most of you guys have realized that, okay? That's not true. Don't rush through, okay? That just means maybe they didn't know what they were doing, okay? I'm going to say that over and over again. It's not a time test, so take your time, okay? Anything else on PSSAs? Okay, I'm sure. Are you guys still working on some practice problems at school, or your teachers pretty much, yeah. Okay, not us in here. We kind of flew through that packet, so. All right, so let's start with the warm-up, the one that was in your homework packet. Okay, it's hard to kind of read. It's hard to, you guys to show me what you got, so. All right, number one, let me just read over these. The table should be -1, 4, and 0. And Zach, this is page 120 in the homework packet. There's my green line. Matt, what kind of function is that? Positive or negative? Good. Okay, number 2, in the table should be 7, -1, 9. Justin, what kind of function is this? Sorry, -9. Justin, what kind of function is this? Nope. How many times does it cross the x-axis? It only crosses the x-axis once. What kind of function is this? It's a line. Yeah, it's linear. My line's just not straight. But it's still linear. Good, and it's positive. Awesome. Okay, number 3, Donatus, can you read the numbers that are in the table on number 3? What? Yep, we're on, Donatus, we're already on number 3 on page 120, yes. Tell me what the y values are. No? Mary? Good. So who can explain, how did you do this on number 3? Briar, how did you do this? Good. Plug the answers in, but then what was it kind of like? Good. So it's kind of like you're solving an equation. Think back to chapters 2 and 3. You should have just plugged, a lot of you guys asked me this, plug the 3 in. 2 times 3 is 6. You then subtract 6 on both sides. So you have 2y equals 2, and then divide both sides by 2. Is everyone clear on how to find the values? Okay. All right. Number 4, Charles, can you read me the y values? Good job. 6, 0, and 3. There's a negative linear function. Okay, number 5. Annalise, did you get to number 5? Okay, can you read us the y values that we should have? Good job. 3, 9, and 4. There's a negative linear function. And Alyssa, number 6, can you read us the y values? Good job. Negative linear function. Briar. Okay, so when you put -3 in, Briar, -3 plus y equals 6. How do you get -3 to the other side? Oh, it's a -3. You want to add it to both sides. 6 plus 3 is 9. That's how you get 9. You okay? Okay, anyone else on page 120? You guys are doing very well with these. Last year, a lot of people had trouble with these ones, so I just kind of wanted to see how you guys did with them today, but good. Based on the warm-up, I'm very impressed with that, so good job. Okay, before I go to the next thing, Adam, can you tell me what function this is and whether it's positive or negative? Don't look in your notes.
It's positive.
Uh-huh.
It's radical.
Good. Positive, radical. What's the equation? Oh, man. Good job, Adam. All right, there's that one. Okay, Jeremy, you're up. What kind of function is this? Positive or negative? No looking in your notes, anyone. I'll give you a hint if you need one. It begins with this. The thing is, you have to remember all the names of them. Hey. Okay. Okay, good. Emma M, what kind is it? Good. Cubic, y equals -x cubed, and it's negative. All right, Sean. You're up, Sean. Okay. Hey, what kind of function is this? Okay, what's the equation? X, Y. Good. Quadratic is always squared. Cubic's always cubed. Okay? Okay, Charles. Actually, Charles, what's another name for a quadratic function? Good. Parabola. Donatus. What kind of function is this? Hey, what? Good. Good. Linear. You got the hardest one. Linear, negative. Donatus, what's the equation? You mean x minus or minus x? No. Okay, it could be, actually. It could be. But Donatus, since it's negative, you have to have that negative in front. Jeremy, pay attention, please. Okay? But you can still have a +4 or -3 afterwards. All right, Alyssa. What is this? Good. Positive or negative? Equation? Matt? Close? Okay, I don't want to hear the answer screamed out. Good job, Matt. Briar? What is this? Hey. Adam, face forward. Positive, negative, what is it? What's the equation? Okay. I blocked this off. Here's a hint. Looks like a V. I don't know, maybe. Emma H, go for it. Briar needs help. What's the equation? Yeah. And don't forget, yeah. Good job. Mary. Correct. It's undefined because of the asymptotes. Remember I told you about the boundary lines? It's good. I'm glad you did that. Yeah. That's because it can never go there. Yeah, cool. Annalise. Well, we're going to work on them. Probably. Every day I'm going to go over them. You'll be fine. Okay, remember, when you first learn something, you're not going to immediately have it memorized. I've been doing this for how many years? So to me, this is easy. Give yourself some time. It's my job to get you guys ready to know them. All right, let's go over the homework, and then I'll go back to the other warm-up, okay? Since you're in the homework packet already. 8.2. Okay, and you guys had 1 to 17 and then 24 to 29. Okay, so number 1, Donatus, we'll start with you. Practice 8.2. Good. Alyssa, number 2. Good. Number 3, Charles. Okay, stay on 8.2, please. Charles, number 4. I mean, Sean, number 4. Sorry, Charles. I didn't mean to do that. Thank you. Okay, number 5, Briar. Good. Adam, number 6. Good. Jeremy, number 7. Good. Emma M, number 8. Awesome. Number 9, Mary, just tell me whether it's yes or no. Good. And then can you also tell me now the values of the y in your table? Okay, what did you use for x? That's why. Okay. You're a little different than me, but that works. So here's what I did. I'm going to show you guys. I used -2, -1, 0, 1, 2. Pretty close to what Mary did. So I got -5, -4, -3, -2, -1. Either way, it doesn't matter what numbers you use. Make sure the graph looks like this. Okay, and that one was yes. All right, number 10, Donatus, yes or no? Good, it's yes. Okay, number 10 is a positive linear function. Yes. My y values, and I always use the same x values. So my y values are 0, 2, 4, 6, 8. So check yours. If you aren't sure if yours is right or not, let me know. All right, Alyssa, number 11, yes or no? Okay, and then what were your table values? Good, and it depends on the order that you put them in your table. So then if you did it as -4, 0, 4, you get 3, 0, -3. Did you have the 4 first? Okay, but a negative times a negative is a positive. So then you did mess up. Oh, I gotcha. Okay, never mind then. So anyways, there's 11. Okay, Emma H, number 12. Okay, and then can you read us your table values? Good job. So here's the table, 3, 2, and 1. Negative linear function. Graphs should be pretty straight. Mine aren't so straight. Okay, 13. Come on, slow smartboard. So, oh man, that's not 13. Sorry. Okay, 13. The table on this one we kind of talked about yesterday. X is -11. So your x should be -11 the whole way down. Y can be whatever you want. Okay? And then your graph on 13, if this is -11, it goes straight down. So it's no. Yeah, thank you. Forgot about that last part. So it's not a function. It does not pass the vertical line test. Okay, 14, kind of the same thing. But they tell you that y always has to be 8. So y is always 8. This can be whatever, okay? And then your graph should look like this. It's a horizontal line going through 8. It's yes. Doug? Because I told you to. The directions here. Because you need to, right now we're just learning how to graph by a table. That's why. I didn't teach you yet how to do without a table. So I want you to have a table for all these. Trust me, this is my least favorite way of graphing, but you need to learn it this way too. Okay, 15, x is 8, so kind of like the other one. 8, x is always 8, and the y can be whatever. So your graph here should be a vertical line going through 8. Adam, is that a function? Good. Okay, number 16. Charles, is that a horizontal or vertical line? Good. 16, your table values. What is it? Y equals -1. Yeah. Y is always -1. X can be whatever you want. It's a horizontal line going through -1. Mary, is this one a function? Good. That one is a function. Okay, now I'm going to go back to my answers that are up here. Annalise? Vertical line test. This is the vertical line test. Okay, number 17. Okay, table values should be -2, 0, 2, 4, 6. Okay, that one is yes, it is a function. You have a positive linear function. So before you flip over, questions on 17. Sarah, if you need a pass, I'll write you one. That's fine. You guys okay with 17? Let me just sign this, and then you can fill it out when you're done. Just rip that off when you're ready. You guys are okay with that? Okay. All right, let's go to the back here. 24 is the next one I had you go to. All right. Annalise, what did you get for 24? Good, and I'm just going to round it to 2,800. Okay, 25, Doug. Oh, yeah, that's right. Jeremy, 25. Good job. 26, Briar. Good. 27, Sean. Good. Charles, 28. Good. Justin, 29. Close, unless I'm wrong. Emma H. Nope. Annalise? Good job. Wow, I'm very impressed. Some of these are hard. You guys did really well. See you, Sarah. Some of them, I said, for you guys. Briar? Wait, why'd you go on Google for 25? Oh. Oh, that's probably because our book probably rounds these, since this is just pre-algebra and not a more complicated math class. I'm guessing that's why, Briar. But what did you get for your answer? Okay, that's fine. You're probably more exact since you got it from the computer, I'm guessing. Again, sometimes the book just rounds things. That's pretty funny. I'm glad you did that. Alyssa? 29. Okay. How to do it? Is that okay, so can I show you? So look, so 29. So you have a minus 1 comma 9. Can someone explain to me what that means? Annalise, what does that mean? Good. Okay. Good. So Alyssa, you're plugging in a minus 1 for x, 9 for y. So you should have 9 times a minus 1 minus 5 times 9 equals -9. So basically, we're just solving an equation for a. Distribute 9a minus 45 equals -9. And then from here, we combine like terms, we move things to the other side. No. I see what you're saying. But do you understand what I'm talking about here, though? Add these and then move this to the other side and then divide by 9. Yeah. The hardest part, I think, was realizing you're plugging that whole thing in for x, this thing in for y. You okay? Okay. Annalise? Number 8. No, you should not get a negative. The reason is you're putting, what are we putting here? Okay, you're putting positive 9 in for r, and then after you multiply that, you subtract that from both sides. So that d, see that negative in front of the d? You end up dividing by a -1 on both sides. I think you probably forgot to get rid of that negative in front of the d. Here, tell me what you just said. Yes. Okay, so then you subtract 108 from both sides. You have negative d equals negative 348. Divide both sides by negative 1. You get a positive. Negative divided by a negative is positive. Okay. Anyone else on that homework, Justin? Yeah. It's a linear function because it's just a line, but it's a horizontal line if we get more specific. Yep. You okay? All right. Anyone else before I go to the other warm-up for a little bit? Okay. Let's go to your notes, page 6. What did you guys think of these? Were they a little easier? Annalise, what'd you say? In the middle? Easy, okay. Kind of like spread out opinions here. Okay, so let's start with number 1 on page 6. All right, we first need the 3 ordered pairs that were given to us. Who can tell us the ordered pairs? Charles, go ahead. No. Ordered pairs are always x comma y. You gave it to me as y first. Good. So negative 1, negative 2, 0, 1, and 1, 4. Okay. Based on the ordered pairs, okay, you guys need an equation. Y equals something x plus or minus something. So, Alyssa, explain. Okay, can you tell us how you got that? Okay, good. Awesome. So, in case you didn't hear Alyssa, the 1 because 0 whatever is always this value. This 3 because as long as your x's are in order from smallest to largest, whatever this y value is increasing or decreasing by goes here as long as your x values are increasing by 1. So basically this number is always the change of the y over the change of the x. No, you do understand what I'm talking about, that pattern? Jeremy, you got it now. Are you mad because now you think it's easy? Is that the problem? I told you that yesterday, Jeremy. Y equals 3x plus 1. I'm not just throwing you out there into the woods here to do it on your own. I did tell you. Okay, so y equals 3x plus 1. Before we go over the next one, does anyone else want me to re-explain what I just said? Okay. Annalise? Well, as long as wherever x is 0, this is the y-intercept. When x is 0, this is your y-intercept. So this number always goes here. Yes. And then as long as these x values are going up by 1, whatever the y values are increasing or decreasing by goes here. Because negative 2 to 1 is 3. You're adding 3 to get to 1. 1 to 4 is 3. Okay? Kind of like yesterday's. Okay, and for it to be a function, it has to have a pattern. Okay, Matt, what did you get for your ordered pairs for number 2? Okay, I'm going to put them in order, though. If you put them in order, it helps. All right, so y equals something x plus or minus something. So what do you guys think about this one? Jeremy, what do you think? Good job. Tell us how you got that. Okay, can you explain it? Good. Good. So when x is 0, that's your y-intercept. That goes here. Okay, and then whatever, as long as you're going in order from you know, smallest to largest or largest to smallest, doesn't matter. Figure out what's happening. Okay, these values are going down by 2, okay, every single time. They're going down by 2 as you get bigger. Annalise? Whenever x is 0. Doug? Yeah. So basically what I should have done, we should be always writing the ordered pairs, the x values, as in increasing order. So I should have always written them this way, Doug. But I'll give you another trick, because here's what I do. So if you write the ordered pairs, the x values in order from smallest to largest, then it's easier to tell what's going on here. These are all minusing by 2. But here's what else you could do. I always look at the graph. If the graph is a negative linear function, this number always has to be negative. So that's why you really don't have to put the ordered pairs in a certain order. I'm actually going to tell you a lot more about that next week, about how to like look at a graph without, forget the ordered pairs. Just looking at a graph, you can get this. But I didn't teach you all the skills yet to get to that. This is more of just looking at the pattern. Okay? Donatus? Go ahead, tell us. Good job. So if you guys want to figure out what Donatus just told us, this is what I'm teaching you guys next week, part of the thing. So do you see how it passes the graph at -4 on the y-axis? -4 goes here. And then the graph from each point, look, it goes down to the right one, down to the right one, down to the right one. That's called your slope. We're way ahead here because Donatus told us. I did, but he gave it to us in different words. I did tell you that, but I told you that by the ordered pairs. I don't know. Did you guys all realize that the graph also went down 2 over 1? Some of you did. Down 2 to the right one, down 2, sorry. So I like doing it this way. But again, we're not all there yet. Some of you guys are still using these, which is where you should be. Annalise? Yeah. X is always 0. It's going to be the y-axis. X is always 0. I think maybe that's where you're getting confused, wherever it is. The x is always 0, and that means that's your y-intercept. That's where it crosses the y-axis. Okay? All right. Let's take a look at number 3. Okay, Briar, what did you have for number 3 for your ordered pairs? Good job. Okay, and they already gave us the equation here. So anyone want to take a guess? Why is there not an x in this one? Doug, why not? Yeah, but there's a reason. Anyone know what number is really in front of x? Mary? Nope, because then it would be 1x minus 5. Justin? Yep. It's really y equals 0x minus 5. Why would the slope be 0 on a graph like this? Emma H. Good. It's not increasing or decreasing. Whenever I look at this, I think of that people mover thing at the airport. Like, so you're on that thing, you're on with your luggage, and it's moving at the same speed. It's boring, right? You just stand there. Okay, maybe you like it. It drives me crazy sometimes. So the people mover at the airport, it doesn't just speed up to make people fall down, right? And it doesn't just suddenly stop to make everyone fall backwards. No, hold on. I'm just talking about the part when you're actually on it. Matt's right. The beginning and the end kind of go a little up and then a little down. But just the actual part that you're on it, it goes at the same speed the entire time. That's an example of when your slope or your rate of change would be 0. Because it's not increasing and it's not decreasing. Okay, when I go running at North Park, if I could run the same speed, my slope would be 0, which that's impossible. Okay, when you're driving a car, if you could drive at the exact same speed, you probably would get a ticket because that means you're not stopping at red lights or stop signs, right? Okay, but anytime you're not increasing or decreasing anything, okay, you have a 0 here. Donatus? Oh, yeah, until it's time to merge and you're still going 80 miles per hour, huh? You're in big trouble. Please don't do that, Donatus. We do like you. Well, we're not in Germany. Okay, Emma. Yeah, I'm sure it's impossible for me too. I mean, it's just hard. So anyways, my point on this is questions on why that would be a 0. Okay, the last one is when x equals 4. Okay, so the ordered pairs here, Jeremy, should be what? Okay, I just put mine in a different order. So, Alyssa, what should the graph look like? Okay, why do you think this one does not have a y equals in it? Why do you think this one does not have a y equals in it? Annalise? It's not y equals 0. If it was y, okay, you could kind of think of it as 0y, yes, and it doesn't have a slope, correct. Justin? Good. So there's something called, it's undefined. There's not a slope here because it's not a function. So Annalise and Justin are both equally correct here, okay? If you have a vertical line and if you try to calculate the slope, it would be something like 4 over 0. So that's like me telling you, we're going to go run today for math class. We're going to run 4 miles in 0 minutes. Is it possible for us to run 4 miles in 0 minutes? Okay, it's impossible, okay? You cannot run, listen, you cannot run 4 miles in 0 amount of time, okay? We cannot create miracles here, all right? We are not superheroes. Okay, but listen, here's what Matt, you're being a little smart with me here. All I mean is 4 miles in 0 time. The time can be any units. I knew someone would say that. So 4 miles or 4 whatever that we're talking about, if the bottom of it is 0, it's impossible. You can't do it. It's like saying, I'm going to collect butterflies. I'm going to collect 5 butterflies every 0 seconds. Okay? You can't do something in 0 amount of time. So that's just a little small preview on why this is like this. I'm going to talk about a lot of scenarios that kind of relate to this, guys, when we get to the graph part. Okay, if you have a question, keep your hand up. Charles, go ahead. No, the slope is undefined, not infinity. It's not a function, Charles. You can't. It's correct, but it is. You're exactly right. But the point of me relating to it as being 0 in the denominator is you cannot have 0 in a denominator when you're graphing. But I understand what you're saying. That's more of a, you'll get to the higher level of thinking of that later. This, a line like this, always has an undefined slope. Okay? Mary? Okay, this should be a question. That's not. If you're starting it today. If you're starting it today. All right, so let's turn in our homework packet to page 121. I did want to do one more thing today, but I ran out of time. That's okay. We had a good discussion today. Okay. Okay, homework packet pages 121 and 122. What'd you say? Okay, so over the weekend or today at school, you're going to figure out why a poor man drinks coffee. Now, listen, here's what I did for you. I typed some tables for you. So if you guys look at page 121, use those tables for page 122. You guys with me? So the equations are on 122, okay? You pick whatever x and y value, well, pick one of them. The other one you're going to calculate, and then plot the points on the graph. Guys, read the directions for how to do the puzzle. Okay, this one's not as complicated as the function one. Promise. No, ignore that, actually. Let me read that. Okay, so let me actually cross off on the directions where it says use the slope and y-intercept. Cross that off and put a table. You should be use a table, it should say. Use the table to graph. Cross off the slope and y-intercept. Charles, you with me? What are you going to use? How can you use a calculator if they're not in y equals form? I didn't teach you yet how to put it in y equals form. All right, that's fine. Then go ahead, Charles. Not arguing with you. That's fine. So use a table, and then it says where the graph is extended. Okay, so let's say number 1. I'm just pretending that the graph goes through R. You would put in the letter R under number 1. Okay? You got it? All right, thank you, Annalise, for bringing that up. I forgot I changed the directions. All right, so use the table, and that's it for homework. Okay, Monday we're going to talk about putting equations into y equals form, as well as an x and y intercept. Have a good weekend. Yeah. No, this is the equation for number 1. Okay? Pick the x values, -2, -1, 0, 1, 2, find the y. Not if you're given an equation that's in y equals, like this one. This one just has a y. So you'd have to pick the y value. Okay? You with me on that? Yeah. You don't have to. No, as long as your problem